Hello students, today we are going to study about all the soil activities which is in the chapter and the topic soil erosion. Okay, so regarding the soil activities, whatever it is in the chapter we will be studying today. Okay, the first activity which you have to perform or which you have to learn is the layers of the soil. Okay, so for that activity it is very easy. Okay, just go to your garden, take handful of soil from there and just keep it in a transparent glass. Okay, and then add water to it, fill it to a level. Okay, and then mix it. Okay, after mixing it, leave that experiment or leave that glass with whole soil water, okay, for at least half an hour. Okay, and after that what you are going to see, you'll be seeing some particles are floating on the surface, and that they are floating because its density is less, and those are the humus which is present in the soil. Okay, below that layer, okay, you will be seeing water. Actually these particles will be floating in water itself. Okay, so here next water you are getting, on water only these humus particles are floating. Okay, now next layer, okay, just below the water is the clay layer. You will be finding that yes, that is the fine soil. Okay, very small fine soil. Okay, that is the clay layer. Okay, and when you go down you are going to see yes, some particles, yes, they are present, and we can recognize it that yes, these are small particles. Okay, and that is nothing but the sand. Okay, and at the last, at the bottom of the glass, what you'll be seeing small particles or the small the stones, pebbles and all accommodated at the bottom layer. Okay, this is how you can just take out the different layers of the soil in a transparent glass, taking the soil. Okay, so this is activity 9.2 where you are taking what? Taking out different layers of the soil. Now the next activity is activity 9.3. Okay, that is what? Working with the soil. Okay, so in this actually we are going to see what? The property of this sandy soil, clayey soil and the loamy soil. Okay, three types of soil basically you have studied: sandy, clay and loamy soil. Okay, so in this you will be taking these three different types of soil. Okay, sandy, clay, okay, sandy, clay and loamy soil. Okay, so in the soil, sandy soil, you take, okay, take the soil actually and just remove all the dust particles and all which is present in the soil. Okay, and you try to make what? Different shapes from that soil. How can you make different shapes of the soil with these three different types of soil? You will try. Okay, so in case of sandy soil, you have taken out all the dust particles, all the other foreign particles which is present, only sand is remaining. Okay, try to add water to it. Okay, mix it properly. Okay, and try to make balls. What you will see, observe it. Okay, same with the clayey soil. Remove all the dust particles and remove everything from there, the humus and all particles, pebbles, everything. Only the clay soil should be there. Okay, now add water to it. Try to make balls. Observe it. Loamy soil, normally you have in the garden. Take it. Remove all the foreign particles like leaves, any small particles, stones, everything. Okay, only the loamy soil should be there. Okay, try to make ball. In all the three types of soil, you are trying to make a ball. What will happen in the sandy soil? Okay, if you are trying to make, when it is in your hand, you'll feel that yes, it is. But as soon as you open it, what will happen? Okay, it will not form, isn't it? In clay soil, just mix it properly, try to make it. Okay, make the ball. You will be finding it, yes, you have made it and it remains. for a considerable amount of time. If you are taking loamy soil, which is in your garden, you are making the ball, okay, it will be made, okay, but not it will be for a large duration of time. It will just again break off, okay. Now, you had made the ball from sandy soil, clay soil and loamy soil, and it formed also, but the time difference was different, okay. Now try to make from that ball only a cylindrical shape. Sandy soil, it will be impossible. Clay soil, yes, it will be, and loamy soil also it will be, but not for a long duration of time, okay. So when we are talking about making of pots, making of surais and all, okay, what we do, which type of soil we take? We take clayey soil, okay, because here you have seen by your own experiment that yes, here the shape remains for a larger duration of time, isn't it? So clayey soil is used for making what? The pots and all of which, whatever you are seeing, the earthen pots and all are made up of what? Clayey soil, okay. You can do this experiment, okay. If not sandy, clay and loamy, whatever soil is present in your garden, take it, remove all the dust particles, pebbles and all, and the other small particles, okay, and just make ball of it and try to make turn it into a cylindrical form. First you will make in the ball form and then in cylindrical form, okay, and see it, observe it, okay. If it is totally hard, after drying it becomes hard and the shape remains perfectly as it is, very nice. Naturally it consists of more of clay soil, okay. But yes, if it is not so perfect, remains for some time, it is loamy soil, and sandy soil, it is impossible to make it into a cylindrical form. So this is activity 9.3 of the NCERT. Now coming to the next experiment, next activity, that is activity 9.4, okay. Here we are going to see what percolation rate of water in the soil. It means how the movement of water is taking place in different types of soil, that is sandy, clay and loamy soil, okay. So percolation rate, if we are talking about this word percolation, means what? Percolation of water means what? Movement of water in the soil. Percolation rate means what? Amount of this water milliliter upon percolation time. It means the water which it is taking, okay, which is flowing and the time it is taking for its movement. Okay? For that, what you are going to take? You will be taking any container, okay, and in this container, actually it should be specific, okay. Same for the sandy soil also, clay soil also and loamy soil also. For this you can take any container. Best is you can take any tin containers, okay, and remove it from the back, okay. And just what you are going to do this, you will be placing it in the soil, okay, whichever type, 3 types of soil you are taking, okay, and you will be placing this can in that, removing the lid from the bottom, okay. Now, and in this, what happens, you will be just piercing it bit inside the type of soil which you have taken, okay. And what you are going to do, you are going to take what? Any container, again I will say, with a specific measurement, okay. Like if you are dropping 250 ml of water, okay, you will take that container. You can take any glass or anything which is present at your home, okay. And just what you will be doing, you will be pouring that inside this first one. Maybe this is the soil containing sand, this is the soil, what is clay soil, and this is what? Loamy soil, okay. Clay soil, sandy soil and loamy soil, okay. First you are doing with in the sandy soil, okay. In this you will just see, you have taken the amount of water, that is how much? 250 ml, isn't it? Taken by any measuring container like a glass present at home, okay. And you will just note down the percolation time, okay. How much time it is taking to take the whole water, okay. And that will give you what? The percolation rate of the sandy soil by the amount of water, like 250 ml you have taken. Suppose it has taken how many? 4 minutes, 2 minutes, how many minutes it has been taken. Suppose if it is the sandy soil, okay, it is taking how many? 2 minutes, okay. Now, same thing, you will be repeating with the clay soil also. Same container, take it in the clay soil, okay, and just keep it over here, okay, and what you are going to do, again pour that 250 ml only, okay. So 250 ml you have poured water, okay. Note the time, okay. Here you will be, suppose it is how many? 6 minutes, okay. It will give the percolation rate, okay. Now here loamy soil, okay. Again you are taking this can, placing it in what? This loamy soil, okay. So in this, what you will be seeing, 250 ml of water again, okay, you have added, and here you are saying that it is taking 4 minutes time, okay. So now in this you have seen 3 different readings, okay, and these readings tells about the percolation rate, okay, how fast the water is moving, okay. So you will be seeing the percolation rate or the movement of water is fastest in the sandy soil, okay, followed by what? The loamy soil, and then the clay soil. The movement or the percolation rate is least in the clay soil. So this experiment you can do properly, easily at home, performing or taking these things which is easily available at home, and you can carry out this activity 9.4. So the next activity is activity 9.6, okay. In this we will be studying about removing of moisture from the soil. Actually the soil which we see, okay, it consists of water in it, okay. So, and different types of soil will contain different amount of water, isn't it? Like if we are talking about sandy soil, okay. Okay, in this soil, percolation rate, if we are seeing, the water, movement of water is too fast, but it cannot retain water. But when we talk about clay soil, okay, here movement of water is very slow, very slow, but yes, it can hold large amount of water. And when we are talking about loamy soil, okay, in this movement of water is average, and yes, it can hold water. Not as much as clay, but yes, it can hold more water, okay. And this sandy soil consists of least water. So it depends which type of soil you are seeing, okay. Just carry out the experiment. Here I have shown you the lab experiment, okay. In this we can take a test tube, okay, attached to a stand, okay. This is a Bunsen burner, okay. We are heating the soil sample which we have taken in the test tube. You can take just the soil present in your garden, again I am saying, okay, and try to heat it, okay. What happens while you are heating, you will see some water vapors are moving upwards, okay. And yes, this is bit the cooler part of the test tube because we are heating from here, okay. We will be seeing some drops, yes, but when you just remove the experiment, okay, remove the burner, okay, you will be seeing water droplets on the upper portion of the test tube, okay. This you can do at home also, okay. Take any glass container, okay, and keep the soil sample, keep it on the gas burner only, keep the flame on the low, okay, and low medium, okay, totally low. It means even heating should be there and the flame should be less, okay. And just see, close the flame, okay, switch off, okay, the flame after some time, okay. You will be seeing water droplets on the side of the container on the upper portion, okay. When you are heating also, you will be seeing something is moving up. So this way you can carry out the experiment at home, but yes, in lab we carry out in the test tube, okay, by heating it with the Bunsen burner, taking the soil sample, and we can see, yes, at the cooler parts we can see the water drops also. Okay, so here if we are taking the soil sample is of sandy soil, okay, it is a sandy soil. So when you are heating, you will not see much water droplets. Okay, but when you are taking clay, you will see tremendous amount of water droplets over here, and loamy, the average of the two sandy and clay soil. Okay, so this says about the water holding capacity of the soil also, and how much moisture the soil is consisting, and this is proving that yes, the water holding capacity of clay soil is the highest or the maximum, and followed by the loamy soil and then by the sandy soil. Okay, understood? So now coming to the next activity, that is activity 9.6. Okay, this is absorption of water in the soil. It means how the water is absorbed in different types of soil, and those soils are what? The sandy soil, the clay soil and the loamy soil. Okay, so for this experiment we need a beaker specifically, okay, and a funnel. In that funnel you will insert a filter paper, making it a cone type, okay, or you can even take any paper, okay, and you will have to make it in the cone form, okay, and insert it in the funnel. And now what you have to do, you have to take the different samples of the soil one by one, okay, and first you will be taking sandy soil, pour water, specified amount of water, okay. Here we have taken, here the weight of the soil is 50 grams, okay, and the water which is specified, having specified volume, so the initial volume of water is what? UML, okay. So you can take any if you want you can take 10 ml, you can take 20 ml, you can take 30 ml, it's upon you, but it should be specific in nature, okay. For all the different soils we will be taking that much amount of water only, okay. So now taken the sandy soil, okay, 50 grams, poured water, suppose 20 ml. Now see, just watch what happens. You will be seeing water over here, okay. So now you just calculate how much water has been accommodated in the beaker as filter rate, okay, and that you will get how? By subtracting what? The initial volume of water minus the final volume of water which you have got. Whatever value you have got, it means that much water has been absorbed by the sandy soil, okay. Now take another cone, make another cone of filter paper. If at home you don't have filter paper, you can take newspaper, you can take any thin paper, make a cone, insert it and add the soil, okay. So now next soil you are taking what? The clay soil. Just pour water in it, okay. How much you have poured in? The sandy soil, okay, suppose 20 ml, okay. You are adding to it. Now what you are seeing, how much water is being collected over here and how much water this soil has, clay soil has absorbed in it. It will be calculated by, again, by the formula of what? U minus V, okay. This is the initial and this is the final volume, okay. And you will also see that yes, in this you have to just wait for minutes for water to drop in the beaker, okay, because in the clay soil the percolation rate, you will see that the movement of water is slow, okay. And yes, how much water is absorbed by the clay soil can be taken out by the formula, that is how much water you have taken and how much you have got over here. So initially you have taken your volume, okay, any specified volume which you have taken earlier also, and this is the final. You will be subtracting it, U minus V, you will be getting the water which has been absorbed by the clay soil. Same will be repeated with the loamy soil also. In that also again add in the filter paper or any newspaper, anything, okay, in a cone shape, add it in the funnel and take that specified amount of soil, loamy soil, that is 50 grams which you have taken, okay, and then just add the water, okay. So initially what fixed it is UML, I have for your convenience, in the book it is UML, so otherwise you can just write any figure also, like 20 ml I have said, okay. And then you are adding and you are seeing the amount of water you are getting over here in the beaker and how it is falling also. Here you will be seeing that yes, the rate of this movement of water in this loamy soil is more than that of the clay soil, okay. And then you will be calculating it, how much it is being absorbed, that will be what? Initial minus the volume, final volume, And in this, when you are calculating, now you will get the amount of water which is absorbed by that particular soil. Okay, and that will say you the difference, that how much water can be absorbed by the sandy soil, the clay soil and the loamy soil. Okay, you can also calculate the percentage of the water absorbed. How will you calculate? Initial volume minus the final volume upon what? The total weight of the soil, okay, into 100. Okay, you can change this volume into weight. Okay, how will be changing? Here, if you are writing volume of H2O absorbed, you will be writing the unit ml. If you are writing for the weight, it will be U minus V. It will be in grams. So here U minus V in grams, because here we have taken the weight of the soil in grams. So you will be taking the weight of the water absorbed by the soil. So U minus V, okay, upon 50 into 100. U minus V, here you will be having the unit gram, and here also gram cancel up. Naturally you will get a pure ratio of the percentage of the water which has been absorbed by the sandy soil, the clay soil and the loamy soil. Now beta, I am going to show you how you will make the cone of the filter paper or any paper, so that you can just add the soil and you can put it in the funnel. You will take any paper like this, okay, any paper, newspaper, any thin paper, but it should be so that yes, the water can move through it. Okay, so here what you will be taking, this type of paper, any, okay, just fold it into half. Okay, and then what you are going to do is, first you have folded it into half and again fold it. Okay, that half also again you have folded. Now what you have to do, take it in this manner. Okay, it should be in the square form, then it will be better more. Okay, and then just take one portion of it and make it in this form. Okay, remove it and make it in this form, and now you can see you have got what? A cone over there, in which you can add your soil over here and then you can drop the water. Okay, and so you can carry out this experiment at home also, taking different types of soil. Now coming to the topic soil erosion. Okay, what is soil erosion? Actually it is the gradual removing or washing away of the topsoil of the area, okay, due to different agents like water, running water. It can be running water, it can be wind, it can be storm, it can be snow. So the top layer of the soil is washed away. Actually the plants which is present, okay, on the soil, it helps the soil to bind, and thereby what happens, making the soil of that area stronger to remain at that place. But if the plants are not there, naturally what will happen, very easily the soil can be washed off by the natural agents like water, wind, storm, snow. Okay, so over cultivation, overgrazing also leads to soil erosion. Cutting of the plants also leads to what? Soil erosion. So we should not cut the plants or trees, okay, because they are only the specific agents which holds the soils properly, okay, to that position. If the trees and the plants are cut off, the soil will not be strongly binded at that area. Okay, so naturally the causes, if we talk about the cause of soil erosion, the main cause of soil erosion is deforestation. If you are cutting down the trees, naturally you are making the soil of that area weak. Okay, it is not firm for that place, and easily the top layer of the soil can be removed out, or it can be washed off with the agents. Okay, these natural agents like water, running water, wind, storm, okay, snow. So deforestation should be not encouraged. Okay, it should be stopped so that the soil erosion can be reduced. Overgrazing should be not done by the animals. If overgrazing is also done, naturally what will happen? The soil will be washed off. If you are adding too much of chemicals to the soil also, that also leads to washing off of the top layer of the soil. Okay, so this is soil erosion, which should not be encouraged at all. It should be stopped, and it can be done by planting number of trees and discouraging what? The deforestation. Okay, so this is all with the chapter soil. Hope students you might have understood it. Okay, good day, take care.